Hello, everyone, and welcome to today's episode on this very channel. We are still on how to list the sample space for a compound experiment. Today's lesson is just a continuation of what we did in our previous lesson. If you have not subscribed to my channel, kindly click on the subscribe button for me. So without wasting much time, let's look at the two examples on the board, starting with this. We are saying that an unbiased die and a fair coin are tossed once. We want to write down all the set of possible outcomes for this experiment. Or the set of possible outcomes is the same as the sample space for this experiment. We are talking about a die and then a fair coin being tossed one, or they are tossed simultaneously. You know that when we toss a die once, we are either going to get, so we have a die, we are either going to get the number 1, 2, 3, 4, 5, or 6. So these are all the set of possible outcomes when a die is tossed 1. This is also known as the sample space. Now when a coin is tossed once, we are either going to get a head or a tail. So this becomes the sample space when a coin is tossed once, and this also becomes the sample space when the die is tossed 1. Now we are going to combine these two experiments into a single experiment, and it becomes a compound experiment. How do we list the sample space for these two experiments? We are going to use the table method. We are going to use this rule to represent the set of possible outcomes when a die is tossed 1. So we have the die, and then we are going to use this column to represent the coin. Let me use the red so that you can see it clearly. So this to represent the coin. So we have the coin and then the die. And then the coin, we have a head, and then so once you are done with this, you just pair the outcome from the toss of the coin with the outcome from the toss of the die. You pair them. So we have head and then 1. So we have head and then what? 1, H, and then 2. So we have H2. We have H3. We have H4, H5, H6. Then you move on to the tail side. We have T1, T2, T3, T4, T5, and then T6. So we have T and then 1, T, and then 2, T, and then 3, T, and then 4, T, and then 5, and then T, and then what? 6. So all these possible outcomes in this arena become the sample space when an unbiased die and a fair coin are tossed 1. So the sample space for this compound experiment becomes H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, and then T6. So these are all the set of possible outcomes when an unbiased die and a fair coin are tossed simultaneously. Let's look at this example. So in this example 4, we are saying that two fair dice A and B are tossed together. We want to write down all the set of possible outcomes for this experiment. We have two fair dice and then we are tossing them together. What are the set of possible outcomes? Now, tossing two fair dice is the same as tossing a die twice. So how do we list the sample space for this compound experiment? We know that when we toss a die means, one die, we are going to get this set of possible outcomes. And then we are also tossing another die, so we have two dice. So let's call this die A and then what? Die B. So we have die A with this set of possible outcomes and then die B with this set of possible outcomes. How do we find the sample space for these two experiments? We are going to draw the same table and then we pair the outcome from the toss of die A with the outcome from the toss of die B. So we are going to use this column to represent die A and then this row to represent what? Die B. With die A, we have the possible outcomes 1, 2, 3, 4, 5, and then 6. And then die B, we have this set of possible outcomes 1, 2, 3, 4, 5, and then what? 6. Once we have this, we pair the outcomes of die A with die B. So we have 1, 1. Then move on to 1, 2. 1, and then what? 2. Then move on to 1, 3. 1, and then what? 3. Then move on to 1, 4. 1, and then what? 4. We have 1, 5, and then what? 5. 1, and then what? 6. Then move on to the 2. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, in that order. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, and then what? 6. Now right now I think you know the pattern. So with the 3 we have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. The same thing applies to 4, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. You can complete the rest, okay? So the outcome in this diagram becomes the set of possible outcomes when two fair dice are tossed once or they are tossed at the same time. As easy as that. This brings us to the end of today's lesson. See you tomorrow. Bye bye.